Here we are on page 18 with the beginning of logarithms. Numbers 13 through 24. Find the inverse of each function. And these are all exponentials that we just did in 1 through 12. So yeah, they're going to be exponentials, and we're going to do the inverses, which are logarithms. Note the domain and range. Well, with inverses, we're switching the x's and the y's places, so the domains and range are going to switch. So we'll note the domains and ranges first. Number 13, this is an exponential. Its domain is going to be all real numbers, and its range was y bigger than 0. So let's make sure and switch those when we do it down here. So here we have switch the x and the y, so we're going to have x equals 2 to the y. Now we're trying to get y by itself. That's why logarithms exist, is that we now say, so y equals the exponent logarithm base 2 of x. So that's how we undo an exponential. We log base 2. Y is the exponent to which we raise 2 to get x is a logarithm. So that's the inverse function right there. We'll call this f inverse of x, and its domain is now, we just switched it from the range, is the set of all x's such that x is bigger than 0. And the range is all real numbers. So whatever this looks like on a graph, that's its domain. You can only stick in positive numbers into a log function, and there's the range. All right, let's do number 14. Its domain was all real numbers, and its range was everything bigger than that horizontal asymptote 5. So it was from 5 to infinity, or y is bigger than 5. So let's switch the x and y places, and we get x equals 3 to the y plus 5. Now let's solve for y. Subtract 5 from both sides, and we get x minus 5 equals 3 to the y, and then we undo the exponential with a logarithm. So we get log base 3 of x minus 5 equals y. That's how we undo logs. And if you'd like to think about it as a log base 3 here and a log base 3 right there, to cancel those, that's great. So this was a g of x, so this is g inverse of x. That's not reciprocal, that's inverse function, equals log base 3 of x minus 5. And its domain is going to be the old range, which is set of all x such that x is bigger than 5. So we can't stick in numbers smaller than 5. And its range will equal all real numbers. And again, it switches the domain and range because we switched the x and the y places. All right, number 15. Here we have switch the x and y places, and we have x equals 4 to the y plus 3 minus 2. Now let's solve for y. Add 2 to both sides, and we get x plus 2 equals 4 to the y plus 3. So now we log base 4 both sides. That's the opposite of exponentiation. And those guys cancel, and we're left with log base 4 of x plus 2 equals y plus 3. And now subtract 3. So we get log base 4 of x plus 2 minus 3 equals y, which we just found the inverse of h. So this is h inverse of x. Oh, good. The domain, we didn't write those down. This normal domain was all real numbers, and the range was everything bigger than -2, we could see because of that horizontal asymptote right there. So the domain is going to be the set of all x's now, not y's, but x's bigger than -2. We can only stick in things bigger than -2, and the range is going to be all real numbers. And this is h inverse of x. Good. Number 16. We switch those places, the x and the y, and we have x equals -2 to the y plus 4. So let's start undoing it. Let's undo this negative here. So we get -x equals 2 to the y plus 4. How do we undo an exponential? We undo it with a log. So we have log base 2, and that goes away. So then we have log base 2 of -x equals y plus 4. Can we get the y by itself? Certainly we can. Subtract 4 now. log base 2 of negative x minus 4 equals y. So we just subtracted 4 from both sides. And this y is the inverse of the function we started with, which is g inverse now. Good. So the domain, we didn't do it up here, the domain was all real numbers, of course, and the range was, what was the range? Well, it didn't get shifted up or down, it just got flipped upside down. So the range was all y's such that y was less than 0. So the domain here is the x values that correspond to the old range values. X is less than 0. And the range is all real numbers. Good. Number 17. H of x equals negative 2 times 3 to the x plus 4. All right, so switching places, we have x equals negative 2 times 3 to the y plus 4. All right, let's peel it off from the outside in. Subtract 4 from both sides, so we get x minus 4 equals negative 2 times 3 to the y. Divide both sides by a negative 2, so we get x minus 4 over a negative 2 equals 3 to the y. And now log base 3 both sides. So we get log base 3 of x minus 4 all over negative 2. Oh, let's draw that all the way down, equals y. All right, so the original domain was all real numbers. That was an easy one. And the range was, we flipped it upside down, so we're going less than 0, and then we added 4. So y was less than 4. So now this domain is going to be the set of all x such that x is less than 4. Interesting, we can't stick in 5, 6, 7, or 8. It'll break the calculator. And the range is all real numbers. Ooh, we didn't label this correctly. We didn't write this down. This is the inverse of h of x. So this is really h inverse of x. Once you've gone through this process, you can label it. It's not just any y equals this. It's a function, an inverse function of x. All right, 18. Let's try 18 now. Ooh, switch the x and the y places. So we have x equals 1/7 4 to the y minus 2 minus 6. Okay, peel these off from the outside in. Add 6 to both sides and we get x plus 6 equals 1/7 4 to the y minus 2. Now times both sides by 7, so we get 7 x plus 6 equals 4 to the y minus 2. Log base 4 both sides, so we get log base 4 of 7 parentheses x plus 6 equals y minus 2. Now add 2. So we get log base 4 of 7 times x plus 6 plus 2 equals y. And y is f inverse in this case. So y is now f inverse of x. Good. Now the domain and range. This domain was all real numbers, just like a normal exponential. And the range up here was, let's see what happened. It stayed right side up and got slid left to right, but that doesn't affect the range, and then moved down 6. So it was the fact that y was greater than negative 6. So now let's switch them. The domain then is a set of all x's such that x is bigger than negative 6, and the range is all real numbers. Good. Number 19. H of x equals e to the x minus 3. So this normal domain was all real numbers, and its range was all the y's greater than negative 3. So y was greater than negative 3. We'll use that as a reference. So let's do the inverse. Switch the x and the y places. So x equals e to the y minus 3, and that will, when we solve for y, will give us the inverse function. Add 3 to both sides, and then log base e both sides, which we called natural log x plus 3. Good. Equals y, natural log of x plus 3. Now its domain is going to be the set of all x's such that x is bigger than negative 3. So we can stick in negative 2, negative 1, but we can't stick in negative 4. And the range is the old domain, which is the all real numbers. Good, and this y is now h inverse of x. Just defined that inverse function, or derived it. Number 20. G of x equals e to the negative x minus 3. Okay, so let's switch the x and the y places. X equals e to the minus y minus 3. Add 3 to both sides. And then log base e both sides, natural log of x plus 3 equals negative y, and times everything by a negative 1. So negative ln x plus 3, good, equals y. And this right here, the y is the g inverse of x. Good. Domain and range. Oh, we forgot to do that. Domain up here used to be all real numbers, so that's good. The range will be all real numbers. The range up here, it was flipped left and right, so that didn't do anything, so it was just dropped down 3. So y was bigger than negative 3. So the domain is going to be the set of all x's such that x is bigger than negative 3. You could also look at, you can never take the natural log of a negative number, so make sure that's positive and you'll get that same result for the domain. And finally, number 21. Okay, so let's switch the x and the y places, so we get x equals 2e to the negative y minus 4. Add 4 to both sides, equals 2e to the negative y. Okay, and then divide both sides by 2, and we get x plus 4 divided by 2 equals e to the negative y. Log base e, also natural log ln of x plus 4 divided by 2 on both sides equals the negative y, and times by a negative 1. Negative ln of x plus 4 over 2 equals y. And in this case, we just found f inverse of x. Good, and its domain and range. Let's look at them. So the domain up here was all real numbers. We had no problems, so the range down here was all real numbers. The range up here was, let me see, this just gave us 0. We multiplied by 2, but it still gave us 0, and then dropped down 4. So y was bigger than negative 4. So this is going to be the set of all x such that x is greater than negative 4. And again, you'll see if you solve for this greater than 0, you will get that answer. Good. Number 22, let's switch the x and the y places. X to the negative 1/3, e to the y minus 2 minus 4. And we can undo this from the outside in. First, we add 4 to both sides. We get x plus 4 equals negative 1/3 e to the y minus 2. Then we times by a negative 3, x plus 4 equals e to the y minus 2. Natural log, so log base e both sides, so natural log of negative 3 x plus 4 equals y minus 2. We just got rid of that e, that's pretty nice. And then add 2 to both sides. Natural log of negative 3 times x plus 4 plus 2 equals y, which is f inverse of x. So equals f inverse of x. Good. The domain up here was all real numbers. That's good. So that's our range down on this one. All real numbers. And the domain here is the range up here. So the range here, let me see, we had greater than 0 as a normal natural log. Shifting it left or right didn't do anything. We shifted it upside down, so we went y is less than 0, and then lowered it so y was less than negative 4. So here it is set of all x such that x is less than negative 4. And you can check that again if you look inside the natural log and you were to set this greater than 0 for a logarithm. You have to input greater than 0 numbers. So we would get x is less than negative 4 if you solved that for the domain. Okay, there we go. Number 23. H of x is 5e to the x. Let's switch them places. X equals 5e to the negative y minus 7. From the outside in, add 7 to both sides. 5e to the negative y, good. Divide by 5, x plus 7 over 5 equals e to the negative y. Log base e both sides, so we get natural log of x plus 7 over 5 equals negative y, and then multiply by a negative 1. So we get negative ln of x plus 7 over 5 equals negative y. There we go, equals a positive y, sorry, which is, we found it, h inverse of x. Good. And the domain and range. Well, the domain up here was all real numbers, so that's going to be our range right down here. And the domain, yeah, is this range. The range, let me see. We had greater than 0, switch left and right, nope. Times by 5 doesn't change it, it's still greater than 0. Lower 7, it's y greater than negative 7. So this is going to be the set of all x such that x is bigger than negative 7. And you could have gotten that by setting this inside the logarithm greater than 0, and you would get the same thing. And the last one, number 24. G of x, switch the x and the y places, negative 3e to the negative y plus 7. That will ensure that the x and y coordinates switch places. Subtract 7 from both sides. Divide by a negative 3. Natural log both sides. And times by a negative 1. Ooh, did you follow all of that? We just did it all in one thing. We subtracted 7. We divided by negative 3, we natural logged, then we times by a negative 1, and we're left with y, which in this case is g inverse of x. So these two are inverse functions. So let's look at that. Domain, well, let's look up here. What's the domain? It was all real numbers, so that's our range down here. That's the easy one. What was our range up on this problem? Our range was, well, we had greater than or equal to 0 times by a negative, so we had y was less than 0, and then added 7. We have y is less than 7. So this is going to be the set of all x such that x is less than 7. And in interval notation, that would be from negative infinity up to 7, open on both of those. Good.